This is Laura Duncan from CSMS. Today we will discuss negative and zero exponents. Let's begin filling in the table. And as we fill in this table, I want you to think of these next ones as fractions. Yes, this is 0.5, but we can also write it as 1/2. The next one would be 1/4. So I want to point out anything to the 0 power is equal to 1. And then each of these, you can see the 2 winds up in the denominator because it has a negative exponent. So let's discuss this property of exponent using words. For this property of exponents, for every non-zero number b to the negative n power is equal to 1 over b to the nth power. To help you remember this, I want you to think of a negative exponent as a very unhappy individual. Wherever he is not happy. So if the negative exponent is in the numerator, change it to the denominator, and then it will be a happy exponent. The negative drops. Let's do some examples. 6 to the -4th, that -4, unhappy. So let's put him in the denominator. Now he's happy. However, that is still not simplified. So go ahead and put that in your calculator or use your mathematical skills, and it will simplify to this number. Let's look at the next one. On the next one, look at the -2. He's not happy. Put him in the denominator then, but do not drop the negative off the coefficient. That doesn't change. However, now that the exponent is in the denominator, he's happy now. So let's simplify it, and we end up with 1/16. In the third example, this one's not happy in the denominator. Well, put him in the numerator. Now we can evaluate. That's the final answer. Another property that we're looking at today is for every non-zero number, b to the 0 is 1. So we have 5 to the 0 power, it's 1. -2 to the 0 power, 1. Anything to the 0 power is equal to 1. Let's do some examples by simplifying each expression. As you look at this, be sure you know the exponent attached to each number or variable. The exponent on the 11 is actually a 1. It's an understood 1. So if I were to separate this into a numerator and a denominator, the 11 would go in the numerator. However, this is a negative exponent. We do not have simplified expressions with negative exponents. So since he's not happy where he is, we're going to put him in the denominator. We drop the negative, he's happy now, and we have a simplified expression. Let's go on to number 2. The exponent on the -4 is a 1. There are understood ones there and there. When we have this -4, it's just a coefficient of a -4. It's okay to have a negative coefficient. We don't want negative exponents. When I see a negative exponent, I go ahead and draw a line for my fraction bar. I know that -4 is going to be in the numerator. So let's leave the -4 in the numerator. However, x to the -3rd power, not happy. So we're going to put him in the denominator. Now he's happy. Notice y to the 1st power though. He's happy where he is. He is with the 4 in the numerator. Now that we have it all simplified, box circle, or cloud your answer. On example 3, that is not simplified, and it's not simplified because we have a negative exponent. No negative exponents. He's not happy where he is. Put him in the numerator, and you're done. As we look at number 4, I like to do what we have done in the past, which is we just multiply our coefficients and add our exponents. So I would end up with -8, and then see this m, it has an understood 1 there. We're going to add the exponents because they're being multiplied. And we have an n to the -2nd power and n to the 4th. We'll add the exponents. So we end up with n to the 2nd power. What we're looking for at the end is making sure that we have no negative exponents in our answer. And so since we don't, this is a good solution. Number 5, let's multiply our coefficients and add our exponents. We have a to the -3rd and times a to the 2nd. That would be a to the -1st power. This is b to the -1st times b to the 1st. We add the exponents, which becomes b to the 0 power. What I want you to understand is I don't write b to the 0 power because that would be a 1, and it's not simplified to have b to the 0 power there. Another thing I want you to notice is that this is a negative exponent. We cannot have negative exponents in a simplified answer. So we'll have our 15. He's in the numerator. Then since it's to the -1st power, the a will be moved to the denominator. Since it's to the 1st power, I do not have to write a 1 there. The final answer is 15 divided by a. On number 6, remember there's 2 ways to do this problem. If you choose to stamp it out, go ahead and pause the video and stamp it out now. If you didn't choose to stamp it out, you may have started with 4 to the 3rd power. This is where most algebra students miss it. And then you'd have a to the -12. Well, 4 to the 3rd power is 64. And this would not be our final answer because he's not happy. He has a negative exponent. No negative exponents allowed. So 64 will be in the numerator, and a to the 12th will be in the denominator. This is our final answer. This is where it gets tricky. On these type of problems, I like to rewrite the problem so that there are no negative exponents. So do you see how a is to the -3rd? I'm going to put a to the 3rd power in the denominator. And we have a to the -5th power here. He's not happy. We'll move him up here. Leave the b's where they are. And then finally, we have c to the 0 power. C to the 0 power is simply 1. So don't even write the c. You're going to not write any c's in your final answer. Now that we have that simplified, we can divide the coefficients. So that would be a -4. Subtract the exponents. 5 minus 3 is 2. And since the 5 is the greater number, it will be in the numerator. Then we look at the b's. 4 minus 2 is 2. And since b to the 4th is the greater number, we will have that answer in the numerator. Please box, circle, or cloud your answer. Please pause the video and try 8 and 9 on your own. On number 8, students find it a little less complicated to go ahead and stamp it out. Then you're going to multiply the coefficients. that would be negative 3 times negative 3. That would be 9. And then I like to go ahead and add all the exponents. Then if there are any negative exponents, later on we'll put them where they need to go. Did you notice z is to the second power? Be very detail oriented as you move forward. So we have an exponent that is not happy. The coefficient stays in the numerator. X squared will go in the denominator. And the other two exponents are positive, so they will stay where they are. Check your answers for 8 and 9, please. And let's do number 10 by evaluating the expression. Remember that when we're evaluating, we're simply solving. So we have 2 to the negative 4th power. Well, we have r, and they've given us a value for r. We will substitute that value. It's negative 3 squared. And then for s, the value is 4. So that would be 4 to the negative 2nd power. So if we're going to set this up so that it's a little bit easier to solve, the only one that's happy where he is negative 3 squared. Be sure that when you are substituting a number, that you use the parentheses. Negative 3 squared is equal to negative 9, and your calculator will tell you so. However, you're supposed to substitute the negative 3 and square the negative 3. That will give you a value of 9, so it is important to know how to put it into your calculator. Now let's address the negative exponents. This would be 2 to the 4th power times 4 to the 2nd power. That makes it a little bit simple. So negative 3 to the 2nd power, as we said, is 9. 2 to the 4th power is 16, and 4 to the 2nd power is 16. But we're not done yet. We need to simplify it until it's a single number, 9 over 256, and that's your final answer. The lesson is yours. Go forth and practice.